Question 4. Ruthenium and osmium are transition metal below the iron in group 8 in periodic table. A. Two different complex ion X and Y can be formed when anhydrous ruthenium chloride reacts with water under certain conditions. Okay, X and Y have octahedral geometry. Aqueous sample of X and Y react separately with excess silver nitrate solution. Different amount of silver chloride are precipitated. Okay, so for the complex ion X is produced 2 moles of silver chloride. So what is the ideas here? Okay, so first you need to understand the ruthenium chloride, it will produce 3 moles of chloride. Okay, once it reacts with water. And here already telling us the complex ions produce X produce 2 moles of silver chloride, means there will be 2 moles of chloride react and form precipitate with this silver. So we know that it will be 1 mole of the chloride will use as a ligand, because total will be 3 moles of chloride. 2 moles already form precipitate with silver, and it will be 1 mole of chloride left as the ligand, which will form dative bonds with the ruthenium. For this complex ion Y is produce 1 mole of silver chloride, means there will be 2 moles of chloride available as a ligand, and it will form dative bond with the ruthenium. So if you understand this relation, you should know is something like this. Okay, so for the complex ion X, how it's produced? One of the chlorides, okay, will exchange with this H2O, and it will form this new complex ion. So because it's already mentioned, 2 moles of silver chloride form, means it will be 1 mole of chloride as ligand. Means in order to form the complex ion X, we just need to use the 1 mole of chloride select. So it will exchange with this H2O and form this. Okay, so we know that the formula of the complex ion X will be this one. Ruthenium with 5 H2O, 1 chloride. Okay, so this is a formula. And follow the same logic, we know that the complex ion Y, it will be this one. Because 2 moles of the chlorides now can use as a ligand, and it will exchange with the H2O here. 2 moles of H2O here will exchange with these 2 chlorides, and it will form this new complex ion. And of course 2 H2O form. Okay, so this will be the formula for this complex ion Y. Okay, so now part 2. Both complex reacts with excess pyrazine to form a mixture of stereoisomers. So this complex ion it has 3 bidentate ligand. It has 3 pyrazine. So means this pyrazine, okay, this structure, it will act as a bidentate ligand and form 2 dative bonds with this ruthenium. And as you can see here, there are 2 nitrogen, and these 2 nitrogens they have a lone pair, and it can be the donor atom, means they are the one that form dative bonds with the ruthenium. Okay, draw the 3-dimensional diagram of these 2 stereoisomers. So for this complex ion, the ruthenium with 3 bipyridine. So this one, it will form optical isomer. Okay, whenever you see a bidentate ligand with a metal cation, so it will form a pair of stereoisomers we call optical isomers. Okay, so what you need to do is you just draw the octahedral complex, because bidentate ligand times 3, the coordination number is 6. So 6 coordination number means it will form 6 dative bonds. So between these ligands and the metal cation. Okay, so you can follow the mark scheme answer, or you can follow mine. So you need to draw the wedge line and the dotted line. The wedge line is it means near to us. Dotted line is far away, is at the back. So this is a 3D drawing for this octahedral complex. And in the question already state, you can use this one to represent the bidentate ligand. So we just use this lah, the end with a curved line. Okay, so make sure the bond angles between the N-RUN is always 90. N-RUN is always 90, because this is a bidentate ligand, right? So it will form dative bond with the metal cation in this way, right? So it's like a crawl of the crabs, so we call silating agent, right? So this one, after you draw this octahedral complex, then on the right hand side you need to draw the mirror image. So imagine there is a mirror in between. So you need to draw a mirror image. So if, let's say, now you draw this bipyridine at this position on right hand side in the plane, so the mirror image you need to draw on left hand side in the plane, and the other ligand is on this one is on top left hand side, this one it must be on top right hand side. Okay, and of course the others one will follow the same way. So this is a 3D drawing for the optical isomer. Okay, I hope you understand how to draw this. It's better for you to practice. B, figure 4.1 show another ruthenium complex. So now this complex only involved one bidentate ligand, right? So this one, and the ruthenium with 5 others monodentate ligand, which is ammonia. And the charge of the complex ion now is 5 positive. Okay, this complex contains a neutral ligand, this pyrazine. So this one is slightly different from the previous bidentate ligand. Just now the position of the N is like this, right? So slightly different. So there are 2 rings here, right? But for this pyrazine, right? So it has 1 ring on it, but the nitrogens now is at 1,4 position here. Okay, 1, 2, 3, 4. And the nitrogen again, it can be the donor atom. We'll use its lone pair to form a dative bond with 2 different ruthenium this ion. Okay, so suggest how this bidentate ligand able to bond to 2 separate ruthenium ion. Okay, as I told you just now. Okay, it will be something like this. So this pyrazine has a lone pair on each nitrogen, right, as I shown here, which can be donated to the ruthenium to form dative bond. Okay, it can form 2 dative bonds. Part 2. This pyrazine is an aromatic compound. The bonding and the structure of this pyrazine is similar to benzene. Okay, describe and explain the shape of this pyrazine. Okay, so since already mentioned, it's like benzene ring, so we can roughly estimate what will be the hybridization. Of course, you can use the type of bonds to identify. Okay, let's start with the carbon because it's asking hybridization. Okay, first it's asked the shape. Then you need to mention the hybridization. Then the last one, you need to mention how the pi bonds form between the atoms. Okay, so let's start with this the shape of this pyrazine. Okay, already told us that it's like benzene, so means it must be a planar structure, something like this. And for this one, because it's all these nitrogen, carbon, they are in the same plane. Okay, so it's like a hexagon. So its bond angle is 120. It's just like benzene. So the shape of this pyrazine is a hexagonal ring planar. Okay, with bond angle 120. So this is the first point. So because it's like benzene, and the challenging part is hybridization. How we identify the hybridization of the nitrogen and carbon together. Let's start from the carbon. See, carbon is here. The carbon is actually from 3 sigma bond. There is 1 hydrogen here. So carbon will form 1, 2, 3 sigma bond and 1 pi bond. So carbon with 3 sigma bond, the hybridization is sp2. So carbon has 4 unpaired electron. So the 3 unpaired electrons will be in the sp2 hybrid orbitals, which used to form the 3 sigma bonds I mentioned just now. And another unpaired electrons will be in the p orbital, which used to form the pi bond. Okay, so this is hybridization of carbon, sp2. For the nitrogen, let's see how many bonds is formed. Nitrogen is formed 1, 2 sigma bond and 1 pi bond. 2 sigma bond, 1 pi bond. So we know that the hybridization of nitrogen is sp2. So why? Because it just needs 2 unpaired electrons in the hybrid orbitals to form the 2 sigma bond, as I told you just now. And because nitrogen is group 15, there are 5 electrons or valence electrons there. So in the hybrid orbitals, there will be 1 hybrid orbitals with a lone pair. So means the lone pair on this nitrogen, okay, is in the hybrid orbitals. And there will be another unpaired electrons in the p orbital, which used to form the pi bond. Okay, so means now we know that the hybridization of nitrogens and carbon, they are both sp2 hybridized. I hope you understand about this hybridization. And the last one, how the pi bonds form. So the pi bond is actually formed between the nitrogen and the carbon. As you can see, carbon and nitrogen. So how these pi bonds form? Okay, as you can see here, in this carbon and nitrogen atom, so they have a p orbital, and these p orbitals, they will overlap sideways, something like this. Okay, this one, 1 p orbitals from the N, 1 p orbitals from the C. So they will undergo these sideways overlaps. Okay, and it's from the pi bond. Okay, so this is the last point. So to form the pi bond, p orbitals from each atom overlaps sideways with each other above and below the ring. Okay, this one is N and C, N and C. Okay, this one is a CC. Okay, so as long as double bonds lah, right? So it will form this 1 sigma bond, 1 pi bond, and pi bond is sideways overlaps between the p orbitals. Okay, part 3. Predict the number of peaks seen in the carbon-13 NMR of this pyrazine. So this molecule is kind of like a quite symmetry molecule. As you can see here, these 4 carbons here, 1, 2, 3, 4. Actually, their chemical environment is quite similar, is identical. Or we can say they are equivalents. So therefore, they will all together will just form one peak. Means you will see one signal only. Okay, only one peak seen in the carbon 13 because all the carbon in this pyrazine, they are equivalent, means they are similar. So, or you can actually mention they have the same chemical environment, no difference. Part 4. The overall charge of the ruthenium complex in figure 4.1, as shown just now, is 5 positive here. Here, right? The charge is 5 positive, and the question actually deduces what are the possible oxidation states for the two ruthenium ion. Since it's 5 positive, we can just assume one ruthenium will be positive 2 oxidation state, another one is positive 3. It can be different. It's just like ion 2, ion 3. Okay, so therefore it will together form this 5 positive. The ammonia itself is neutral, and this bidentate also neutral. So therefore the charge of this complex ion is controlled by the metal cation. So we just put positive 2, positive 3. This is a combination. Right, that's why we have this. Okay, deduce a possible oxidation state for these two ruthenium ions. Okay, I just put positive 2, positive 3. Okay, part C. Osmium tetroxide so reacts with the alkenes in a similar manner to co-dilute acidified NO4 or permanganate ion. So figure 4.2 shows a proposed synthesis of condensed polymer G. Okay, so now it started with this dicarboxylic acid. So undergo step 1 to form this diacyl chloride, and after that this cyclohexene will oxidize by this oxidizing agent and is formed the diol, because it say it just like the co-dilute acidified KMNO4. This one you should have learned in AS. So it will oxidize the CC double bond and form diol. So eventually it will form this diol. So means later it will be a reactions between this diol and this diacyl chloride. Right? Okay, part 1 suggests a reagent for step 1. So to convert this dicarboxylic acid to this diacyl chloride means we need to use these 3 compounds: PCl5, PCl3 with heat, make sure you put with heat, and SOCl2. You can use either one. So by using these 3, so the OH will substitute by this chlorine, right, to form this acyl chloride. Now part 2, draw the structure of exact one repeat unit of the condensation polymer G. Again, polymer G is produced from these 2 monomers. So let's see what will be this repeat unit for this polymer G. And it's mentioned the ester linkage should shown fully displayed. Only the ester linkage. Okay, so let's start with, okay, this part you no need to draw. I just show you how the condensations happen. So it's a reactions between the OH and this COCl. Okay, so the HCl will combined and removed. After that, the C and O will form a new bond here, right? As means it will form the ester linkage later. It's between these 2 monomer. So eventually it can form this repeat unit. But one thing that is very important, you must show the dotted line here. Don't show the OH here. So because the O always will form the another bonding with others, right? And the C here also will form another bonding with others. So on the O here, on the other side, you need to put dotted line. on the C here, you need to put dotted line also. Means this is a polymer chain, and this is one repeat unit. Okay, it must show the ester linkage must be shown, right? Okay, so that's all. Thank you.